friends, so let's talk about the basic concepts of two-way ANOVA. ABC produces eye drops to relieve minor eye irritation. Researchers have noticed that the eyedroppers on the bottles dispense varying amounts of fluid depending on the product line, product A or product B. To ensure that the customers obtain a consistent amount of eye drop for each product, they want to investigate two different eyedroppers dispensing the two different products. They want to compare how many millimeters of liquid the current and modified eyedroppers will dispense of both the original and sensitive products. Earlier in the chapter, we discussed how we can use one-way ANOVA to examine differences among the means of one factor, such as differences among the strength of fibers from 5 different nylon suppliers. In this case, we have two factors, uh, dropper type and product type. So how can we make this comparison? When we have two factors, we can use two-way ANOVA to investigate differences among group means. Before proceeding, so let's review some key concepts from one-way ANOVA that are equally important here: the factor, the level, and the response. Factors are the explanatory variables we are studying. In two-way ANOVA, there are two factors. For the eye drop example, the factors are dropper type and product type. Levels are the groups or categories that comprise a factor. The current and modified eyedroppers are the two levels of dropper type. The product A and product B are the two levels of product type. The response is what is measured in the study. For the eye drop study, the response is the volume of eye drop that is dispensed from the dropper. In two-way ANOVA, we also need to understand two more items: main effect and interaction. The influence of a single factor on a response is called the main effect. If the modified eyedropper dispensed more liquid than the current eyedropper, that would suggest that a main effect for dropper type existed. An interaction between factors is present when the mean response for the levels of one factor depends on the level of the second factor. An interaction between eyedropper and product type would exist if the average response for the levels of eyedropper depended on the level setting of product type. For example, if the current eyedropper dispenses more of the product A, while the modified eyedropper dispenses more of the product B, an interaction exists between dropper type and product type. Let's consider another example. ABC company employs a variety of software developers to provide customer software solutions to its clients. On its staff, the company has programmers, uh, software testers, and system administrators. The manager wants to determine how to best leverage the company's training programs, which include classroom teaching, instructional videotapes, computer-aided instruction, and one-on-one training. While the manager knows the training is costly, it can save the company money in long run if the right employees are trained in the best way possible. The manager wants to know if training method and employee job type influence the effectiveness of training, as measured by the score on a test taken after the training is completed. We can use two-way ANOVA to determine this. If a particular job type achieves higher scores from using a given method of instruction, while for the other job types, the method of instruction has no impact. So is this an interaction or main effect? An interaction between factors is present when the change in the mean response across levels of one factor depends on the level of the second factor. In the ABC, we might see an interaction between methods of instruction by job type. For instance, programmers might more effectively retain knowledge gained with computer-aided instruction, while method of instruction has no impact on other employees. So let's review. We can use two-way ANOVA to investigate differences among group means when we have two factors. A main effect is the influence of a single factor on the response. An interaction between factors is present when the change in the mean response across levels of one factor depends on the level of the second factor. Thank you for your listening. In the next lesson, we'll talk about the graphs.